I can absolutely watch the chat session if somebody, as long as you tell people to put @Mike or something like that.
Perfect.
Thanks for correcting me.
Yeah, sorry, Alex. Give it one more minute. Do the slides show up as sort of scrunched for other people, or is it just me?
Show the next one.
Looks
Yeah,
fine to
hands, Eric.
have this.
Your window. It looks pretty reasonable. There's like white space on the top and sides, but I think that was just how the presentation was.
Okay, I'm probably holding it wrong. Okay.
Try resizing your window. I had that happen earlier, and I had to just drag the window around until it unsquished. But that seems to be a browser-specific thing in MeetEcho.
Yeah, well, at least we figured out the MeetEcho bug on the PDF. If anyone's using Google Slides, you have to change your sides to export, otherwise it looks horribly pixelated. Anyway, sorry.
Which I believe we have done for everything in this session. So
yes, so we should be all set.
If it looks horribly pixelated, it's...
Yeah, I think we can get started. So welcome everyone to the Masque meeting for the week. Excited to have you here. I'm sorry for those who, perhaps this doesn't align with the best hour of the day, but such is life, I guess. Next slide, please. As usual, this is being recorded. Everyone who's here has likely used MeetEcho before. So if you want to, speak at the mic or jump in the queue, just use the little, handy tool on the left-hand side to enter yourself in the mic. We'll try to call on you in order that you appear, just so everything's done in an orderly fashion. For those people who, well, specifically Watson, who volunteered to take notes, who may not be looking at the queue or may not recognize your voice, it'd be helpful if you just say your name before you start speaking, just so we can note it down. Next slide, please. So this is the note well. If you have not seen this before, I encourage you to just take a moment to read it here or either online. Just a friendly reminder to be respectful, courteous to others during the meeting, and hopefully this will be productive and useful to everyone. Here's some useful links that might help you along. We have a link to the agenda here. You can also find it on the data tracker. Link to the notes in the Jabber room, which is also relayed here. Thanks for clarifying that to whoever did that. If anyone wants to help out with notes, to add more detail or whatnot, feel free to also, jump in and help Watson out. He took notes during an earlier session during the day, so I'm sure he could use a little bit of a break. Next slide, please. All right, on the agenda, we have a number of things. First up is to go through updates to ConnectedDB and HTTP3 datagrams. David's going to talk about the interrupt status that took place last week. a reminder of which on the Quick Dev Slack channel, there is or server, there is a Masque channel during which we're sort of organizing the interop, or in which we're discussing the interop. So if you want to participate, send Eric or myself an email to get added to the server, or anyone who's in there. I think anyone can add anyone. Don't remember the details. And we'll get you squared away, and you can dive right in and get going. David also talked about draft updates and some open issues. After that, we're going to pop over to the second sort of leg that this work group focuses on, and that is Connect IP. We're going to quickly revisit and review where we are with the requirements documents, just basically nailing down, or confirming what has been nailed down. And then we're going to talk about the two proposals that are on the table, both helpfully called Connect IP. So we'll just refer to them as Proposal 1 and Proposal 2 in no particular order. And then we're going to have some discussion afterwards, hopefully, to help decide on a path forward, or decide or figure out what's missing and what's not, and what have you. All this is as time permits, based on how much progress we make with the Connect UDP and HTTP3 datagram stuff. As is usual in Masque conversations, we tend to run over with certain things. So the Connect IP stuff may be truncated, and so we'll just play it by ear when we get there. And then finally, if after all that time still remains, then Lucas will talk about some HTTP3 datagram and priority stuff. So I do apologize in advance, Lucas, if you get bumped. I assume you're okay with that. Before proceeding any further, does anyone have any questions, comments, or want to make any changes to the agenda? All right. If not, let's Eric, can you do the magic to share things with David?
Yep. So I think, David, you need to click the button to enter the slide queue.
I miss standing in the pick box. That was fun times.
You could put like pink tape behind you on the wall.
No, there's one right here.
David, are you going to click the slide button?
Oh, sorry. I hadn't realized I needed to click a button. Is it the ask to share slides? Okay. Oh, and then I get to pick which one. Oh, fancy, fancy.
Go crazy.
Oh, neat.
Very nice.
Okay, should I just get started? I guess so. All right. Good morning, afternoon, evening, middle of the night, everyone. So my name is David Skenazy, and let's chat about Masque, HTTP datagrams, and Connect UDP. Next slide, please. Ooh, I have the buttons myself. So previously on Masque, so quick recap of where we are today if you haven't been paying attention. So big item in our charter is building Connect UDP. So it's Connect, but not for TCP, it's for UDP. And some of the requirements that we picked up along the way is that it needs to work over all versions of HTTP, so 1, 2, and 3, and across HTTP intermediaries. And that becomes really funny when the intermediary is operating on one leg with one version of HTTP and on one leg with another version, but we'll get into details about that later. And another important thing and reason that we're doing Connect UDP today and not 20 years ago is when we're going over HTTP3, we can use the quick datagram frame, which gives you really nice performance properties because you're not retransmitting lost UDP packets. That said, there were other working groups and people interested in using HTTP datagrams without Connect UDP. So in particular, one IETF effort is web transport. So we decided to kind of split the Connect UDP draft into two, where at the bottom is an HTTP datagrams layer, and Connect UDP kind of sits as a user of that. And that way, web transport can have a dependency on HTTP datagrams without depending on Connect UDP. So we had a Masque interim in April of this year. mainly on the talking about HTTP datagrams. We kind of paused the Connect UDP layer above until we kind of solve some design questions there. And at that meeting, we kind of pretty much redesigned everything. And after discussing this on the list and reviewing and on GitHub, we merged some PRs and submitted a new revision. So let's go into details as to what has changed between IETF 110 and this week's IETF 111. But first, let's talk about interop. Still great. So previous draft versions had like the full matrix set up, but with the new draft coming out not that long before the IETF, we had Ericsson and Google build full implementations of the latest draft, and we were able to interop in both directions. So we're very excited. And another point that I want to really highlight, Apple shipped a really cool thing called iCloud Private Relay. Tommy gave a cool presentation in PERG earlier today. But what that means for Masque is all this is built on a double Masque proxy, which is based on Connect UDP. So Apple and its mysterious CDN partners that I'm not allowed to talk about, but that are clearly in the room and whose IPs are foundable by Whois, all have Connect UDP deployed in production. So this is currently using the earlier version of the draft, but it really means that what we're building here matters at internet scales. We're talking about hundreds of millions of users, not some niche. So I'm really personally super excited about that. So what changed between last time and this time? So a big change is that we decided to strongly associate datagrams with the HTTP request that is associated with them. So what that means is we kind of removed the flow ID, which was the single variant at the start of the datagram for demultiplexing, and we replace it by the stream ID of the associated request. And since in HTTP3, requests are on client-initiated bidirectional streams, which in Quick V1 are divisible by 4, we just encode a quarter of that because that means we can save some bits in the variant encoding. And these datagrams can also carry a context ID, which is optional. And the idea there is for applications that need it, you can have a second multiplexing layer with some negotiation or declaration capabilities that allows you, for example, if you have an IP tunnel on one context and you want to compress the IP header or the IP addresses in some of them, these can coexist on the same conceptual request and on the same, so datagrams with the core quarter stream ID field. And we're going to go into more detail about how you communicate these encodings to your peer so they know the format of the datagrams you're sending. Another thing is, since we've agreed as a working group that we need to support versions of HTTP that before 3, so that go over TCP, we need a way to send datagrams, and in this case of Connect UDP UDP packets, over streams. And so that was originally done using something called stream chunks, which were a sequence of TLVs on the data stream. So what I'm calling the data stream is in HTTP 2 and 3, it's what's in data frames. HTTP 1, it was like the only thing that was there. Some details there, but anyway. And the problem there is the original design, we were just thinking, well, we can just put everything in data, and that way the intermediaries don't need to think about it. And so the problem is what happens in the scenario that we have a diagram here for, where the intermediary is speaking HTTP 3 to the client on one side, HTTP 2 to the server on the other, and some stream chunks are flowing, and then a datagram frame comes in. The intermediary needs to kind of inject that kind of between two TLVs, so it needs to pick a moment in the stream to inject it. But in order to do that, it means that it needs to be parsing the entire stream of TLVs, and that kind of completely breaks down the architectural purity we had of, okay, the data stream is something that intermediaries don't touch. So because of this, we decided to switch to a new approach, which is capsules. Thanks, Ben, for the name, even though I know Ben's not too excited about the name. And so the idea there is, if the data stream isn't great, how do we get information end to end between the client and the server in the presence of intermediaries? Because you can't just use HTTP2 or HTTP3 frames, because these are hop by hop. If a frame arrives at an intermediary, it only has meaning from there. The intermediary is not going to blindly take it and forward it on the other side, especially if it's a frame that it doesn't know. The spec says you just drop it on the floor. And so what's a capsule? It's just like, it is a new type of frame, but it has a new semantic, which is when an intermediary receives a capsule, even if it doesn't know what this capsule is, it copies it and forwards it onto the stream that it would forward the data on. And that gives you kind of a new extension point to HTTP that allows defining new capsules, but you don't need to change the intermediary every time. You only modify the intermediary once. And then the way we'll define this for H2 is kind of probably use upgrade and define a new protocol that is a sequence of capsules, but we'll cross that bridge when we get there. Let's kind of agree on this design first, because we had some traffic on the list and just wanted to make sure, let's kind of pause and have this conversation. What is the best way here? Kind of, so stream chunks works in the data stream, capsules work. One difference that makes me kind of prefer capsules is that it keeps the data stream open. You could use it for something else. But apart from that, they both are very similar. They both mess up kind of the existing HTTP semantics, so they become an extension to the semantics, depending on how you think about it. But then it becomes an architectural discussion, which means we're at IETF, because both work, we can bike shed. So Martin, please tell me what you think.
I think with is not that they're a new frame type or whatever, or not that you're inventing a new, well, actually it is. It's that you're inventing a new end-to-end semantic for the protocol. And I'd like to see a little more motivation than both would work for doing that, because this is a fairly major thing to do. One of the nice things with just putting stuff in the content of a message, or the whatever the thing is with Connect, because Connect is weird, is that you can just do this on top of your existing stack if you don't need all the H3 stuff. And that's probably something that I'm interested in starting out with Masque. Maybe not initially, but we can get something working and demonstrating that it works just by, I have an existing stack, I tell it that Connect UDP or Connect IP does whatever it does, and then I can handle the contents according to the protocol. Maybe I don't get datagrams, but no, that'll work.
So, and I think, the not having datagrams kind of becomes the crux of the issue at the end of the day, because that's the motivation of why we're doing this. Like, it's because Quick is the way it is that we have more need for be able to proxy UDP, and we have the opportunity of proxying UDP efficiently. And if we my real take is to focus on the version with datagrams, get that working the best in the world, and then an earlier version of HTTP should be supported, but not quite as a first party. So that's my take.
Yeah, I think that's probably fair. But if you imagine that your API is only widened to include the ability to send datagrams related to a stream, which is essentially what the datagram draft does, then you get that capability without a significant additional increase in the surface area of your application. You're not talking about writing new HTTP2 or HTTP3 frames in order to get these things working. You are just, okay, we've got the ability to access the stream of bytes that is being sent in bidirectional fashion, and the ability to send datagrams or create new streams in HTTP3. So I think that offers a far more incremental path to getting the outcome that we're looking for.
My thought there is it kind of depends on which, so we had discussed this on the list a little bit, on which sets of servers and intermediaries you want to kind of optimize for. Because I mean, for the client, it's kind of the same way. I think a client that's going to be deploying this is going to be doing datagram work. So they're already kind of performing surgery on their quick stack, either way with either of these. And then it becomes interesting on the intermediary. And like maybe for folks who are at other companies and have other deployment models, I'd like to hear them as well. At Google, we have a front end that speaks HTTP3 to the clients and then versions over TCP to the back end. So that split one is kind of my personal main focus. And for those, with either one, I'm going to have to perform some deep surgery because it doesn't have the ability to look into data frames. And it's actually less work to go look at HTTP3 frames because we kind of recently built that parser and it's pretty extensible. But like you're saying, you know, it's if you're focusing on a different one, then the sets of priorities varies. Mike?
I kind of echo Martin's point that I'm not totally sure this is the right way to build it, but it might be. I'm intrigued by the idea of what are basically end-to-end frames. I kind of question putting them in the H3 datagram draft because there's nothing specific to datagrams about them. It's just the first customer. And so if we actually need that, I almost feel like it's something we should ask HTTP for or send them a draft or something. But I'm also, so the question that I had, and I think you just answered it, but I still want to raise it in the discussion. Connect UDP doesn't have to be satisfied by a UDP on the other side. It could be satisfied by the proxy making its own Connect UDP request upstream. That's already described for Connect in the HTTP semantics doc, and it works effectively the same way for Connect UDP. What matters is that the thing that gets your Connect UDP request can respond, yes, I can get your datagrams there. And so even if they're hop by hop, if a regular frame is hop by hop, if it is able to then make its own Connect UDP request upstream and somehow relay the datagrams, that's okay. And so going from a side that connects supports quick datagrams to a side that supports capsules or stream chunks or whatever, it's okay for the intermediary to inject new frames because it's making its own request. Now, you said your implementation has constraints that it's not able to parse data frames. And that, I think having that constraint on a particular implementation is an argument for capsules. I don't know if we should design around that one implementation though. So I'd kind of like to know whether whether other implementations have that same constraint, or if looking at it as terminate Connect UDP and service it by making another Connect UDP request lets us get away with frame types.
Thanks. That makes sense. Let's hear from the other implementers. Tommy.
So I got on here to riff off of Martin's comments. Because just coming from the implementation perspective alone, not looking at the doc, I am sympathetic to that, and I do think there are things about using the data stream that would be attractive from the implementation standpoint. So like the way that we built Masque in is as a layer on top of the HTTP protocols that can go on top of H2 or H3, and it just handles all of the logic around the proxying. So for datagrams, yes, we did have to kind of expose, like, here's a new datagram stream you can peel out. But other than that, it just kind of is used to using the stream as the way to communicate data down into the HTTP layer. So I do think that having yet another flow of data, so like you'd have like the stream data, your datagram data, and then capsules. it does make it a more complex abstraction that now you're asking a more generic HTTP layer to implement. So I do think the question comes down to, like, is Connect UDP just layering on top of normal semantics, or are we saying that we do need a new semantic in all of HTTP? And is that something that we expect kind of all of these HTTP APIs to build in ways to do capsules and not just think about this use case? So I do think that if we want to go down that road, we may want to bring it into HTTP to talk about the overall implications on the architecture. So I would like understanding, like, why couldn't we do this on the data stream? Just put the capsules on the data stream itself and have that be what Connect UDP uses, and maybe not have that be part of like the H3 datagram layer itself.
So, I think that was one of the points that Martin was making. So yeah, to be very clear, both of these would work, and that's kind of why we end up in these trickier conversations, because if only one solution worked for everything, then we wouldn't be discussing it. Yeah, the data stream is definitely doable, and if folks do prefer that, we can go back to it. I think defining the how, I think it makes sense that the HTTP datagrams document defines how to convey HTTP datagrams over HTTP2 or over HTTP1. There is value in using datagrams over multiple versions of HTTP, and that's true for Connect UDP, but that's also true for Web Transport, and I'm sure there'll be more. Because and it'll be like, I think, widely deployed when the client will use quick datagrams to go to the first hop intermediary, and then often over the back end, it's fine if you're using H1 over TCP, like you're on an over-provisioned data center network there, so you don't, like, the benefits of quick are way smaller. So it's possible there. If we say that, that's why for me it makes sense to have like capsules, or if we want to call them stream chunks, whatever, inside the HTTP datagrams document. I had initially brought that document to the HTTP working group and to say, like, should we have this there? And kind of the response was, this is a new kind of semantic that's cool, but that we don't need to have there. So go do it in Masque, and please come back, when you were a working group last call. And a lot of the HTTP enthusiasts are in the room, so I don't think which room the document lives in is like the most important part. Alex?
Hi, thanks, David. I just wanted to add some color from our experience implementing Cubone. It was built in the same binary that David was referring to earlier. However, one of the things that we did is that we didn't have the constraints of wanting to interop with the HTTP stack on top of Quick. And we actually, in fact, ripped all that out, and we replaced it with our own data stream that wasn't HTTP. And we used that to exchange what we sort of call control data. And I think that's actually an interesting observation as to the type of data that we're talking about conveying on these capsules, which leads us to want to think about whether or not it should be a frame in HTTP or data on top of existing data frames, which is, what is this intended for? And I would claim that if it's a data frame which is intended to be sent to the origin server and interpreted, that is a different semantic than if it's intended to be used by a front end, such as, for example, the Google front end, to make some different decision. And one of the things that David mentioned of, like, well, we don't want this particular type of intermediary to inspect over the data stream because that's not good, actually is exactly that mingling. So in having these separate capsules as a separate first-class HTTP data type, it means that we can have a logical separation as to what is actually in HTTP versus what is actually one of these higher-level protocols. And it means that we avoid, like, reinventing new protocols and multiplexing strategies on top of HTTP. Like, one of my personal goals for IP proxying is I don't want to come up with yet another way of exchanging TLVs along with intermixed data frames of some sort. And I would like us to have a way to convey both the control data and the datagrams, be they unreliable or reliable, delivered. And what I really like about the capsule proposal over the stream chunk proposal is that it helps, at least for me, mentally fit better into what is HTTP and what is some higher level data.
Yeah, that makes sense. And then to add to that kind of briefly, one, because data in general is kind of, for most of HTTP is the message content. And so we consider HTTP as, like the semantics of HTTP are request response, where there is a message sent up in data frames followed by a message coming down in data frames. In whatever we build here, stream chunks or capsules, you kind of have this bidirectional flow. And some of these, given that we're kind of giving it to the application to the side, could potentially be server initiated, for example. And that's true of stream chunks and of capsules, and there are features that can rely on that. So we'll discuss that in the Connect IP section at some point. And that's why it's just kind of strange to me to put it in data frames, because it's not those semantics, it's something different. But again, it would work. Martin?
Hi, as an individual, I'll say I don't have a strong opinion on this, but I do want to push back on the fourth point that because I think there are intermediaries and there are intermediaries. There are people where you're trying to do like datagram transition to H1 or whatever, and yes, absolutely. In that case, you have to change it anyway. But there's certainly plenty of boxes out there that might be in the path that currently do H2 to H1 or H3 to H1 or whatever that don't support datagram, that could absolutely pass stuff in data frames without any difficulty and translate them between protocol versions. But if you have some random new frame, it's just going to drop them. So I think it is a barrier to deployment that we would have to overcome. Thanks.
I don't have a good intuition for how common these boxes are, but you're totally right about them. I agree.
Well, for instance, like a big IP or an Nginx load balancer today, supports Quick in HTTP3, but not datagram, and so it will absolutely drop frames that they don't recognize.
That makes sense. Thanks, Martin Thompson.
Made the point that I really wanted to make originally, which is that this is really about building on top of HTTP and building on top of the version-specific versions of HTTP, so H3 or H2. Now, I realize, of course, that the real value here is when we can build on specifically HTTP3, because the others don't have datagrams. But at the same time, if there is a conceptual layering on top of HTTP that we can exploit, there's a lot of advantage here. There is one point that I think we haven't gotten to yet, which is the flow control for the control messages that you're talking about exchanging here could actually become critical, particularly when you look at the Connect IP scenario where you have to, you start a transaction and you have a bunch of routes that you add, and then you end the transaction, you're expected to commit all of those things at once. There's some buffering requirements, and flow control probably has to apply there if you don't want to avoid getting into some problems.
A clarifying question about flow control. So for either of these proposals, they'll be on top of a Quick stream or an H2 stream, which has its own level of flow control. And is that what you're referring to, and that's sufficient, or are you talking about flow controlling in, let's say, number of capsules / chunks, which neither proposal has today, at least?
Yeah, so what's curious about capsules is that if you have capsules in HTTP3, they're flow controlled, easy. If you have something similar in HTTP2, they are not, and it's not easy. And so things get wacky because only the contents of data frames are flow controlled in H2.
I forgot about that detail of H2.
Yeah,
that is a good point.
And so things get complicated unnecessarily, I think, when you start to invent new things. And then, of course, the whole extension, semantics, and all those sorts of other things. So my preference would be to look at the HTTP semantics as much as possible, and then extend from there. And that might have a better chance.
I mean, that makes sense to me. Thanks. Victor?
Can you hear me fine? Okay, so one thing that we discussed at some point with datagrams is what is specifically responsible for defining semantics for datagrams. And I think with Capsule, we would kind of have the same problem, is that in theory, you could send capsules for everything. And that's one of the reasons I find sending stuff on data much more attractive, because it is much more clear that for Connect UDP, the semantics for Connect UDP data does come explicitly from the method and not from anything else. And similarly with extended Connect and Web Transport. So that is one point. And in general, I just find all of the Martin's argument quite persuasive. So that's roughly what I wanted to say.
Okay, thanks, Victor. Jana?
Where the mute button is. Hi. Cannot hear me. Cannot hear me?
I can hear you, John.
Okay, wonderful. I'm not going to repeat the points that were said. I think that I'm definitely leaning towards using existing data as well. But I think one point that you said earlier, that you went to HTTP and they kicked you over to Masque, saying maybe go solve this for Masque if it's a local problem. What I'm seeing on the chat is that it's not a local problem, that it's shared potentially with web transport as well, and sorry, WebSockets as well. And if it is the case, then maybe it is something that belongs there as a way to extend HTTP semantics. I also want to ask, I haven't seen. Yeah, go on.
Specifically, I think Datagram, like if we forget about this capsule/stream chunk for a second, Datagram itself is, like, I think no matter how we slice it, a new kind of HTTP semantic. And that, like, was very clear that they were saying, like, that's what Masque is for. Like, you don't need all HTTP semantics to live in the HTTP working group. That's what the HTTP chair. So if they want to jump in and say something, go right ahead. But that's what they were saying. I don't think there's a requirement for any kind of changes to the semantics to live inside HTTP. We just need to make sure they're aware, and we've been doing that, I think.
Fair enough. I mean, I don't want to speak for them, of course. But I was going to also ask if you don't see it doesn't seem to me like from your slide here, it doesn't seem to me that you see this being a deployment hurdle, basically introducing a new capsule or a new frame type here for HTTP. But I'm hearing that it is a potential hurdle. I don't know what you think about that, because I'm trying to understand, I'm trying to break this down in terms of the difficulty of deploying both of these things. And it's not clear to me. It seems clear to me that capsules will be much harder to deploy because a new chunk type and a new frame type. Oh my God, I'm getting all of my nomenclature wrong today. Anyway, that maybe that is the argument for not doing capsules, because it's fucking confusing.
Yeah.
But
I mean,
yeah.
So I was working with a set of assumptions, kind of a little bit specific to our implementation, but I'm getting a clear sense in the room that folks seem to prefer data frames. So I mean, that I'm happy to go back to my implementation, give that a try, see if there aren't any like complete roadblocks there, and then maybe we switch back to something. That's on the table, obviously.
Yep, fair enough. Thank you.
There is one question though in general, because we kind of, as often with how these things go, multiple changes happen at the same time, and so we were mainly focusing on a new frame capsule versus using data frame and then stream chunks or however we want it inside the data stream. So sounds like there's a strong preference here for data frames. So happy to switch back to that. The other change that happened around the same time was moving this from Connect UDP into the HTTP datagram document. And I want to make sure that folks are okay with that. And the reason it was moved as well, kind of around the same time, is When we did the split from flow ID to stream ID plus context ID, you needed a way to negotiate context ID. And that kind of had a requirement on something that went across, so stream chunks or capsules, hence why it moved down. So are folks okay with that that part, which is, let's say, the stream chunks, living in the HTTP datagrams document? Because I think that even if we switch to data frames, that part makes sense to me, but I want to make sure that I'm not in the minority here. So Lucas?
Hello, can you hear me? Yeah, sorry, I
Yes.
should have turned this off. Yeah, I don't have much to add. I think just to the question you asked, I entered the key before that, but I think it is the right thing to have these located in this document. Connect UDP now is quite a simple document. I think for people coming into Masque and like, what's this Connect UDP thing? It would just build on top of other stuff that people have implemented because it's general purpose. But what I was going to say is, having taken an implementation that we did last time for the interop and tried to change that to be capsule frames, I kind of fell into this trap of treating them like full HB3 frames, and I got stuck because I couldn't parse them properly. And actually, what I probably need to do is treat them like data frames, so that they're opaque bytes that I would throw up to the application, and it would be responsible for parsing the capsule contents and deciding what to do, and then driving my library again. So that's kind of where I got stuck and why my interop entries weren't there, because I couldn't bootstrap any Connect UDP effectively. So I kind of feel some of the statements that people are saying, that it would be nice just to be able to grab some stuff and write some user space code and crack on and test this stuff out. It would be sad to have to go back from all the work we just did on capsules, but that was part of the question that we answered in going to a dual layer model, right? And I think actually we could, if we had to, do this on data stream, but maintain that dual layer context ID, stream ID, stuff like that. And my feeling is we still have consensus of keeping that part of the design, even if not capsules. So thanks.
Have many buttons, but one of the things we cannot do for you is unmute you.
Wow. Sorry, everyone. All right. Where did I start? Oh, yeah. So the sense I'm getting is that folks do, like a lot of folks prefer using data frames. So let's switch back to that. But I don't think folks are suggesting kind of reverting everything that we did along the way. So I think keeping this two-layer and also keeping the fact that HTTP datagrams now work across all layers and define the stream chunks in there sounds preferable to me, because we got some nice properties out of that, negotiating context and all that, even if we switch away from a new HTTP frame and back to the data stream. So if you disagree with that, please speak up. Alex?
Thanks, David. I mostly wanted to ask the question of making sure that we're continuing to make progress here, because one of the things I'm a little bit nervous about is that the capsule proposal came out of people being kind of unhappy with the multiplexing that we were doing over the data stream. And now that we have this proposal, people are now unhappy that we have a new frame type. And I'm sort of wondering which is the one which is more impure that we need to agree is worse than not do. And I'm not currently sure that we're thinking about it that way. We're instead just looking at the current proposal and saying, we don't like that. The other one was probably better. And then if we have another meeting 3 or 4 months from now, we might change our minds again. So what can we do to make sure that we don't keep flip-flopping here?
Oh, okay, I'm unmuted. So thank you, Alex. I think that's a very good point, because when we switched to capsules, this was discussed on the list, and we had quite a few people comment in support. And now it was kind of strange to be like, oh, now everyone's against. Did I miss a meeting. So I agree with you. It would be, I'm totally fine going back here, but it would be great to not keep flip-flopping for the next decade because, you know, we have people who want to ship this stuff. Tommy?
Just to that last point, to Alex, like I think this is progress. I think seeing it both ways is important, and then people can make a better judgment on it. And if you want to cement it down, we should ask for a consensus call. I don't think it should be in this meeting. It should probably be on list. But that's how you move forward, right? Regarding, David, your question about, you know, what are we keeping? What are we going back to? Yeah, don't revert everything. It's progress. It's good. Regarding where stream chunks go, I want to just raise the question, like, the use of stream chunks depends on what your data stream means, right? And so it is very dependent on the method. So at the very least, if we're keeping in HTTP datagram, it should be very clear, like, here are the requirements on methods that can use this and methods that can't. You know, presumably, like, we want connect UDP and connect IP to use the same thing, and they can be different methods, but that this is not going to apply to a get or a post. So, like, there are ways that it will not work. So you could define it in the methods themselves, but that's not necessary. For the case of web transport, I just want to understand, like, how is it?
Wait, but before you move on, can I answer something on that one? So the way I'm thinking about it, and this is kind of very fresh just from this meeting, so I'm probably forgetting about some things, but one part of, okay, is this in this document, in that document? Sure, duplication of text, not the end of the world. And then if we put it in HTTP datagram, you would say, okay, this is what a capsule data stream means. So, you know, we'll find a cool name for it. And then ConnectGDP would say, I choose my method to use a capsule data stream. And boom, you use it. I think the one difference that actually matters between having it live in HTTP datagram versus having it live in ConnectGDP and ConnectIP is the capsule types IANA registry. Do we want one registry at the HTTP datagram layer, or do we need every single method to define their own? I think that becomes kind of the one distinction between reusing it and just putting it in there. What do you think?
Yeah, but that's fine. I mean, having it in a common place, if we want to use the same semantics and the same registry between ConnectUDP and ConnectIP, is fine. Like, I guess it could be its own third document, but let's not go there. And then for web transport, because I know web transport wants to use datagram. Does it want to use stream chunks too? And how? Remind me.
So I'm going to let Victor, who's right behind you in the queue, jump in to answer that one.
Okay.
I mean, you can stay on, Tommy.
I'll stay on. I'll mute.
Okay, so the comment I was going to make is approximately yes, that now if we're running the capsules over data, now we are in a position where your method basically has to use string chunks, and it has to use string chunks if it wants to use context, and that's a solvable problem because you can move context out of datagram into connect or something else. But what's not solvable is that if you want to have seamless bridging between H3 and H2, you need to have like a datagram capsule. And that basically means you have to have some way of conveying it. That's universal. As for whether web transport wants to use that, the answer is yes. I have at least two issues where which I need to write APRs that are solvable with something like capsule, because web transport currently doesn't have a good way of indicating things like the reason the session is closed or session level go away, which is like all requested features for which we had consensus that we should implement them, and that involves some form of stream of chunks on Connect stream. And I was when that was open, like in March, I was going to write a new thing, and if H3 Datagram provides that, I will not have to. So from that perspective, that is.
Thanks, Victor. I think that's a pretty strong argument for it living at the HTTP datagram layer, in my opinion.
Right. And to be clear, the method it's using there is just a plain connect.
It is RFC 8441, or I don't remember number, extended connect.
Right. So it's a connect with, and presumably that extended connect would allow it to.
Yeah, extended connect allows you to put whatever payload you want.
Right. Okay. And so that's a very nice thing there. So like your extended connection reference, like, oh, I'm using this interpretation of the data stream. Good. Yeah. Let's do it.
Awesome. Yeah, and I think on the question of like, having this like unified INI registry does mean that you define datagram, a stream chunk for datagram or a datagram capsule only once, which I find pretty appealing. All right, I think we have a path forward. I'll write up a PR for this that kind of moves back to data frame, but without reverting anything else. And I do ask that people like really spend the time to think about it and look into it on the list. So we don't have to go revisit this at the next IETF. But I think we've made some good progress, and I totally understand that it took actually seeing a draft with capsule to decide what we liked or not. All right, and now in the 13 minutes I have left, I will go through the next 10 slides. Obviously, since this was not necessarily what I predicted, the slides are going to keep talking about capsules. But let's just say that they're still capsules, but they're going over data frames now, and just do that mental substitution. So in order to carry datagrams over HTTP 1 and 2, you need a datagram capsule. And that's kind of all there is to it. It also, for the rare applications that want the ability to reliably deliver a capsule, to reliably deliver a datagram over HTTP3, they get that feature for free. So there, we define a capsule for that. It's simple. Then kind of context. So that was an addition since the last IETF, where with what we were kind of calling the two-layer design, as opposed to just having a flow ID, now we have the stream ID, which tightly couples to a request, and then an optional context ID that gives you a second layer of multiplexing for cases where you want to do different compression contexts on the same connection again. And here comes the protocol police. So the namespace of context ID is, again, a variant, so 62 bits, we shouldn't run out. And similar to other things in Quick, the even ones are for clients, the odd ones are for servers. That means you don't need any synchronization to build your own. And this is what we discussed at the interim. All of these contexts can be used bidirectionally. So let's say if the client says, I'm going to use context 0 for foo, it starts sending datagrams with context 0 for foo. The server can also send datagrams with context 0 for foo. And registration is kind of a unilateral declaration of, hey, I'm just going to do foo with 0. That is what that means. You don't get to decide. Like 0 is, I'm the client, I own 0, so I get to send this. And the way you do that is with a register capsule. And then we also added a closed datagram context capsule. So for example, if let's say you're doing a compression and you say, okay, I want to register context ID number 4, and with associated, this is the IP header that I'm going to compress, and you start sending, and after a while, the server's like, okay, I am like really low on memory, I want to save some, you haven't been sending any datagrams on this, I need to garbage collect. All right, just FYI, I have now closed this context. I'm not going to be, I've flushed all my state, so if you send with it, those are going to get dropped on the floor. So we added that. So here's that example that I'm mentioning where let's say you're so you have your connect IP request on stream 44. And so you're sending datagrams with your core stream ID 44 divided by 4, which is 11. And you just say, okay, context ID 0, I'm not sending any extensions. That is just a raw IP packet. And you send for that. And then after a while, you say, well, maybe I should compress, because it turns out that this user just created a TCP connection to this specific host and is sending a lot of data. maybe let's compress the IP addresses, TCP ports, however you want to do your encoding scheme, but you use a separate context ID, which is 2, and when you register it, you use this extension mechanism to say, let's this is the format / the semantics of datagrams with this context ID, which means that your peer is going to use that information to decompress the packet and then shove it back into its stack. So kind of switching gears to Connect UDP here. So the draft was pretty much on hold while we were redesigning HTTP datagrams, to the point where I let it expire for a few days. My apologies. Drafts shouldn't expire, but that's a different question. Now that we've kind of moved some of this functionality to HTTP datagrams and decided that HTTP datagrams should support all versions of HTTP, the Connect UDP draft is way shorter. It kind of just says, hey, use HTTP datagrams. A UDP packet matches a HTTP datagram. Done. And then there are some semantics there, but it's kind of a lot cleaner. And that felt really nice, being able to rip out so much text in that draft and have something pretty simple. Now, for everyone's favorite activity, in the 8 minutes we have left, let's see how many GitHub issues we can discuss. So on the topic of extensibility, so when I was saying for this IP extension, you need the IP compression. These register capsules have a way to do extensibility. That's kind of nebulous, and the issue is we have some examples here in the documents, but mainly from the issues and the lists, a few folks were like, how do I use this? Because it's true, the documents themselves have this extension joint that's not really used. And so right now it has a format that looks really, it's just, I stole it from quick transport parameters, which is, this is a sequence of opaque TLVs. And then the T's are registered in IANA registry, and TNLs are varants. Done. That allows you to encode just about anything, which is great. But do we need that much? Some folks, I forget who, were saying pretty reasonably, if you're defining, if this means, this is the format of my datagram, because for a context is in order to send datagrams with that context, you don't need 2 formats. You only need 1. So maybe you don't need a sequence of these TLVs, you just need a T and a V. And that kind of makes sense. I guess the only difference, whereas you would want one of the other, would be, okay, what about extension composability? Let's say you have Connect UDP and you're sending UDP packets. Someone writes an extension that says, hey, I'm going to add a timestamp right before my packet. So if this context, if I register my extension, it means that there's 8 bytes of timestamp before the UDP payload. All right, that makes sense. Let's say someone does the same thing for a completely different extension that does a byte with ECN bits, for example. What do you do if you want 2? Actually, and also, how do you order them? Is that something we want? Is that something we don't want? Please discuss. Line up at the mic. Martin, go ahead.
The immediate question is, capsules are ostensibly end-to-end, yes, but contexts are hop by hop?
No, sorry, I forgot to say that. Contexts are very much end-to-end. So that was one of the tweaks in the 2-layer design. The stream ID is very much hop by hop. The context ID is very much end-to-end. The intermediaries are not supposed to look at the context ID at all.
Right. So in a scenario where you have an intermediary who is maybe taking things from datagrams and putting them on the stream, or taking from the stream and turning them into datagrams, they don't need to know about this stuff. This is something that's negotiated end to end.
Completely, yeah. And the big feature there was it allows you to deploy extensions to Connect UDP or Connect IP by only modifying the client and the server without having to modify any of the intermediaries along the way.
Yeah. So inherently, you have the ability to ensure that the datagrams, whatever they are, however they're expressed, get there end to end. So why does this need to be an extension to an existing message and not just a new message? Thinking of keeping the number of joints small and well greased, that's more likely to be well greased, isn't it?
So that makes sense. The way I was thinking about it was kind of a layering thing where at the HTTP datagram layer, it doesn't know anything about the format, and it just has a way to say, here is a datagram. Tell me to send a datagram and with what context, and here, tell me what context it is and what that format means, and I will kind of shove that bag of bytes. If every single thing needs to define its own register, so what you're saying is every new format would define its own register context capsule type.
I'm not
right?
saying it would have to, but it could. So there's a potential point in the future where you go, oh, well, there's the combinatorial explosion that we're starting to see. Well, let's just define an extensible one. And then you have an extensible register context ID. You don't necessarily have a close necessarily that would be extensible in the same way. And so that gives you a bit of flexibility without having to fully anticipate all of the necessary extensions that someone might want.
Yeah, I mean, both. I totally see that. I think both of them work. I'd have to think about it some more. Do you have thoughts on composability?
Basically, in the same way that you would avoid adding new extension points to protocols, because every new extension point needs to be looked after. And unless you're absolutely sure that this one is needed, then don't make it, because you'll then have to look after it forever.
Yep, that's fair. So let's see. So let me kind of reiterate what you're proposing, which is, so we have a register datagram context, which kind of doesn't have this extensibility field. And that means like that just registers whatever the method said it does by default. And then if, let's say, someone wants to build Connect UDP with timestamps, they would define a capsule, a separate capsule, which is register datagram context for Connect UDP with timestamp. Or actually, you can even forget the first one. Like Connect UDP would have to define a register context, which means just plain old UDP payload. And then anytime you have a new format, you would define a new capsule type.
That would work. And
that would
the
work.
number of things that you're looking to add here are relatively small and constrained based on what I'm seeing. There's the work that's been done for IP compression potentially. There's the stuff we're using potentially in QuickLand for removing connection IDs and other sort of things that would be redundant. And so I think there's an opportunity here to just simplify a little bit. That's all.
That makes sense. I'll have to like kind of look at all the use cases we have and one by one and see if it works. But my intuition is that it does. And I agree with you that fewer INI registries is a good thing. Not just for that, but fewer things to maintain in general. Anyone else have thoughts on this? All right, or I guess not. And I'm pretty short on time. So, Lucas, go ahead.
Just quickly to say, I think what Martin proposed sounds very similar to what we can do today, but cleaner, and that tidying up close and making that easier sounds like a good thing to me.
Cool, thanks. Given that we only have a minute, I'm gonna pick one issue because we kind of already discussed it a little bit. So right now we have kind of a weird thing where, Connect UDP and Web Transport have things in common. They're kind of our first two main use cases for HTTP datagrams. And one of them uses Connect UDP as in a brand new method. And the other uses Extended Connect, which is regular Connect, but with the protocol pseudo header. Which is reminding me, how do we do that for HTTP1? And so both of those work, but it's kind of odd that we're doing different things. Should we do something about that? Is it fine? Victor?
I mean, the reason they're structured for that, because they're kind of different things, despite being both called Connect. So Extended Connect is not So Connect UDP is Connect in traditional Connect sense, that is, you're connecting to some remote server. That is, and your HTTP endpoint is a proxy. Extended Connect redefines Connect, meaning that instead of acting as a proxy, it is acting as an actual resource. That is to say, the reason it is called Connect is originally it was defined for WebSockets, and you're kind of proxying to your like real WebSocket server, but you don't have to be proxying. Like this is a resource as is. So from that, this is the reason Web Transport uses Extended Connect, is because Web Transport is also that kind of resource. At least that is my perspective, and the reason I wrote the original draft like that.
That makes a lot of sense. Thanks. All right. Kazuho, go ahead, but I think we should stop after because we're over time for this presentation. Go ahead, Kazuho.
My point that I made in the previous interim, that with Connect UDP, we have an interface with existing intermediaries that buffer all the requests prior to processing it. Whereas Extended Connect goes around that issue. So regarding interoperability, I think Extended Connect is superior.
Okay, thanks. Let's, oh, I'm realizing we don't have an issue number for this specific one yet. So I'll go and file one. Let's keep the discussion going there. Cool. And I think I'm done with this. Let's
David,
see.
real quick, Eric Nygren was trying to talk. I don't know if he still wants to or not. He was popping in and out of the queue.
Go ahead, Eric.
Yeah, I was just going to say that the it looks like issue 23 has a bunch of that discussion in it, and I think there was it seemed to be leaning fairly strongly in the direction of using something more like an Extended Connect and actually having putting more of the information in the path rather than the authority.
Okay, so then let's continue
Roy was actually pointing out that it would actually not be valid HTTP to use Connect UDP the way the draft currently specifies.
That makes sense. All right, so let's then issue 23 it is, and while we're there, we can figure out the scheme because that is generally required as well. So everyone, if you have thoughts, please jump to issue 23. All right, that's it for me. Back to you, chairs.
All right, thanks, David. So surprisingly on time, we're going to now transition over to the Connect IP section in the meeting. I'm going to try and join or share the chair slides. One moment. I don't know if this is working. Can someone confirm?
I can see that.
You can?
Yes.
Excellent, thank you. All right, moving forward. Okay, so between the last meeting and this meeting, we were trying to nail down specifically what problem we were trying to solve with the Connect IP piece of this whole working group. We did a working group last call and solicited external reviews from various areas for just the purposes of getting more eyes on this particular document. And the outcome was mostly consensus on the contents therein, with a couple of exceptions. In particular, there was one use case that was sort of it lacked consensus across everyone who chimed in. And then there was one additional requirement. I'm forgetting exactly which one offhand, but I probably should have noted it here. But there's one additional requirement that was also rather, or didn't have a very clear consensus. So as a next step to make sure that we have sort of a stable stake in the ground, chairs Eric and I are going to work with the editors to sort of incorporate some of these editorial things and update the document, take into account the result of that working group last call, spin a new version, and then just sort of park it. And that'll be useful for us in trying to assess or just make sure that what we are trying to solve when we actually embark upon, the assessment of the Connect IP solutions is in line with what we previously agreed upon. With that said, today we have two proposals on the table, both helpfully named Connect IP or a new method for Connect IP. Alex is going to talk about one. I believe Miri is going to speak about the other. Due to the fact that these are very similar, obviously, in terms of what they're trying to solve, the hope is that we can have just two presentations, each of which are time boxed similarly, and each of which questions will be restricted to, or ideally restricted to, just sort of technical clarification. We just want to make sure that we have sort of a shared understanding of the proposals on the table. And then afterwards, when we sort of open up the discussion to evaluate sort of what was just presented and then figure out a path forward, then we can start, asking more high-level questions. In particular, Eric and I would like to encourage folks to keep in mind sort of two very high-level general questions when these presentations are happening. First of which is, which of the options, A or B or both, satisfy the desired use cases that are in the requirements document that have gone through working group last call. The second of which, what set of features that are presented are essential in order to satisfy those particular requirements in those use cases versus optional, or things that can be pulled out into extensions and what have you. And we'll once the presentations are done, we'll come back to this slide to sort of again help frame the discussion. But I imagine there will be very lively chatter afterwards. So with that, I'm going to. Well, actually, with that, are there any questions about sort of the way this is going to go about? Okay, hearing none, I'm going to stop sharing and then ask that Alex request to share his slides.
Hello, everyone. Can everyone hear me?
Yes, I can hear you.
So for people who don't know me, I'm Alex Janohovsky. I work at Google with David Snowsy and a bunch of other folks. I was hoping that Dallas McCall, who's worked a lot on the IP proxying requirements, would be here today, but to my knowledge, he had other commitments and could not be. I'm here to present a draft that three of us have put together on Connect IP, which is our instantiation that we are proposing of taking the IP proxying requirements that we've been working on for the last few sessions and trying to actually start an implementation. So a little quick overview of what Connect IP is. The goal is to create an IP tunnel between some endpoints. And this itself can be used in a couple of different ways. One example would be sort of a consumer VPN. If you probably have watched a video online, you've probably seen lots of people talking about things like NordVPN or Surfshark, which people use in order to move their internet connection somewhere else, use it while traveling. You could also use it for a point-to-point IP tunnel. So this is something where you might imagine having containers on a whole bunch of different nodes that want to securely talk to each other, potentially with a protocol which doesn't inherently have its own security. So this would be sometimes called an overlay mesh. Another useful use case would be a point-to-network IP tunnel, like a corporate VPN, where you're trying to go and connect to a secure environment for your work. And the last case is a network-to-network IP tunnel, also called a site-to-site VPN, where you might have multiple parts of a network that need to securely connect to each other, once again, with protocols which may not have inherent security. A lot of these use cases come from the IP proxying requirements draft, and we're not going to spend too much more time on them unless folks have questions. So let's sort of dive into what we think we need for our solution. fundamentally, we believe we need datagrams. So we think that the IP packets, sorry, not think, we are speccing out for the IP packets to be conveyed using HTTP datagrams, either the quick datagram frame or from the previous conversation we were just having, the datagram capsule. Obviously, whatever we have here, subject to change to whatever we're going to be actually doing an HTTP3 dgram. Going back to stream chunks would absolutely be a possibility if that is the way that folks are currently leaning. In either case, no matter how we are conveying these datagrams, in the base instantiation, the payload will be a full IP packet starting from the IP version field up to and including the last byte of the IP payload. But of course, that isn't set in stone. Any extension that wants to support additional formats, such as the IP compression use case, which has been described a couple of times, can register these additional formats using the registered datagram context field that we have been describing in HTTP datagram. But in order for this to actually work, we need to briefly go and talk about forwarding packets. So the mental model here is that Connect IP endpoints effectively act as IP routers. So that basically means that when they receive an encapsulated packet in the mode of operation where we're not doing anything other than conveying the full IP payload, so obviously this would be subject to small tweaks if we do have extensions which change that, they would need to parse the IP header. They would need to check any local policy, such as source address validation, which is to say, don't allow spoof packets or something like that. And then finally transmit it using an implementation specified mechanism, such as raw sockets. And in the reverse direction, if we're receiving a packet which is bound to one of these Connect IP tunnels, we would need to do the same checks, but in reverse. Rather than source address validation, it would be destination address validation, for example. So again, the same local policy checks happen there, and then finally it's transmitted inside of the Connect IP tunnel rather than transmitted using the implementation specific mechanism. So in order for this to be functional, though, since one of the capabilities that we have is in fact IP packets, one of the things that we need to do is be able to have IP addresses. So one of the things that we believe we need is the ability to explicitly request an IP address to be assigned, and also a way to respond saying, here is an IP address. These messages are pretty straightforward. They merely include the IP version, the actual bytes, and the prefix length if necessary. The prefix length is allowed actually so that way this address request could actually be an address range request, which is particularly useful for IPv6. If we wanted to be able to natively support things like IPv6 with privacy extensions, we could support requesting an entire /64 range and have normal IPv6 work as usual. Obviously, IPv4 address is scarce, and I suspect that almost all the times the IP prefix length would be the maximum 32 bits there. And there's, by the way, one thing which we do explicitly state in this draft is I don't believe we say it is any requirement that this be request response. The address assignment could be immediately responded and granted by the server. It does not need to wait for the client to request for it. Ecker, I believe you're in the queue.
Yeah, I just want to note, like, I don't think this is an invalid thing to do, but I just want to note that, like, it's what the reason you require it is because you're attempting to bridge two networks, not because you're attempting, because in the VPN use case where what I want to do is, like, you know, is I got a client and I want to, like, just conceal my IP address, you don't need to do that. You just NAT. And I think that actually tells you that you also need, so I just want to like register that point. And that tells you definitely need a range because, like, lots of network bridging cases where, like, you don't have a single IP address, but you have a whole block. So I just want to, like, just like clarify that point.
Thank you, Kerr. I believe that's true, but if that's specifically, if I understood correctly, you're talking about the presence of the prefix length, not necessarily the presence of the request and assignment messages. I believe we need.
What I'm saying is, if what I want to do is, like, just, like, pretend to be in, you know, in Europe when I'm actually in the United States, then actually I don't even need to request an IP address, because what I do is I just connect and let them NAT on the way out the door.
Oh, I understand. I think in that mode of operation, if that's all you want to do, I would actually suggest that you not use Connect IP, but instead use Connect UDP or regular Connect. Because
I generally agree with that, but I know people who, like, seem to want to use Connect IP for this purpose.
Well, for people who do want to use Connect IP in the way that you describe, I do believe an IP address is necessary, even if it's an RFC 1918 or equivalent private space address. Otherwise, a virtual network device, I just don't know how to make it work in the current OS APIs.
Okay, I see your point. Thank you.
Tommy?
Yeah, just to comment a bit on what Ecker was saying, like in your response, I do think that for that use case, yes, using Connect and Connect UDP is great. That's what we're using for private relay and stuff like that right now. However, there is a good use case for doing Connect IP, even in that. Let's say, I wanted to be able to say, ping this host name. And in that case, I really do not care what address I have, or even the address of the other side. So I think that's where having a mode in which we are not required to request an address and assign an address, maybe there's just a default you put there, maybe there's a mode where it's always compressed. And I think that's kind of what the other draft gets to. That is a valid use case. And there should be some way to make it happen without having to have addresses be exchanged like this.
Okay, I think I see the point you're making there, and I personally feel that if we want to allow a mode where a specific implementation is always overriding the IP header to provide a specific address, we can do so. I don't think that what we are currently proposing here precludes that. We simply would just say don't use these messages. Perhaps we would probably want to add another message to say that you intend to operate in this mode so that you know what values to write in there. I'm personally a little bit worried about making sure we get the OS security correct there, because normally things like ICMP are done with net raw. So I think there's a lot more to think about doing there if we do want to support that particular mode that you described. I don't think there's anyone else in the queue, so I'm going to move on. One of the other things that we believe we need is, specifically if you're going to be doing something like a VPN, corporate VPN, or consumer VPN, is you need to know what destinations you can reach using this. One pretty typical mode is that you want to go and put most but not all of the traffic into this mode. So for example, for a consumer VPN, you're not going to want to tunnel the VPN traffic itself, because then it would break. And you also presumably don't want to tunnel the local RFC 1918 addresses of the home network itself, since you might have smart devices that you might want to continue to work. So we have these set of messages for route advertisement, route rejection, and route reset, which is to allow the peers to communicate which routes they're willing to accept. The endpoint, it does not need to actually accept these routes. It could choose to ignore it and can apply any sort of local policy here. So like, for example, if a client wanted to say to a server, hey, I want to go and announce for 8.8.8.8, server probably can and should reject that per its local policy, since we probably don't want to allow those sort of hijacks. So what do these messages actually sort of look like? They're pretty similar to the IP request, IP response ones that we had before. I'm sure you're all very surprised here. Once again, we have the IP version, the IP address, and the prefix length. Here we need it to be a prefix length, since in fact you could go and announce that you are willing to relay traffic on behalf of a portion of the internet. So like one potential example way that you could do this, if you want to say do the consumer VPN, is say, hey, for IP version 4, address 0, prefix length 0, I'm willing to go and route all traffic. But then you can go and say route rejection, by the way, for 192.168.0.0/16, I'm not going to convey any of this traffic. So you could go and have these two advertisement and rejection messages in that order and implement the message exchange required for a consumer or potentially even commercial VPN. So that sort of probably brings up this question of, well, why do we also have this route reset? And the answer for that is that internet routes change over time, and we want to be able to allow these long-lived connections to take these updates. With the way that we currently have these messages structured, a rejection explicitly says don't route this, and sort of undoes the route advertisement for a particular range. And we just basically added the route reset as a shortcut rather than having to explicitly say go and reject any previous thing that we have had, which allows the server to not have to keep track of what updates it's previously sent the client. We now have another thing, which I suspect is probably going to raise a few eyebrows, which is called atomic start and atomic end. I know that we've already gotten some GitHub comments on this before. The goal here is we want to avoid race conditions on these routing messages. So the idea behind atomic start and end is that they merely convey that those sets of configuration, for which currently there's only the routing updates, need to be applied together atomically. And what that means is if we go back to that previous example I said of, hey, route 0/0, then reject 192.168.0.0/16, it means that there wouldn't be a period of time where we start sending like internal network bound traffic to one of these Masque endpoints, because those rules would be installed in a routing table, quote unquote, atomically, where atomically needs to be implementation defined. Obviously, I know that some routing engines can't install such rules, but in terms of like software logic, how we want it to work, that is how we want it to work. So basically these two capsules, start and end, would just basically say all of these config statements need to be applied together. Then we have a convenience capsule, which is just shutdown, which is to help provide peer information as to why we are telling it to go away. This is analogous to the go away support that we have had in quicker HTTP in previous iterations. So it's primarily intended for debugging. So for example, you could imagine a server going and saying here, server is going away, or for maintenance, or maybe connection was idle too long, and just have a nice convenient thing for debugging here. So now I think it's sort of time to talk about extensibility, since we have talked about not too many different capsules, or potentially stream chunks if we go back to that. So there's a couple of different ways that we can go and extend Connect IP in this proposal. We can use HTTP headers, we can use the capsule types, or we can use the datagram context extensions. And there's a couple of different ways of doing this. So for example, we can go and say, hey, here's how you configure DNS servers when you're using this VPN over Masque as capsule. We can put authentication or authorization data as an HTTP header when we do the initial connect, maybe like a cookie. We can support sending a compressed IP payload by registering another datagram and putting in the metadata here of saying, here, for 192.0.2.6, this port, put that in for me when we go and send these payloads. And that sort of allows us to do all sorts of different things using sort of these existing mechanisms. We're not, in Connect IP at least, inventing another extensibility point. We intend to use the ones which we've already been discussing. And that is all I have at this point, unless anyone has any questions within the guidelines that the chair set.
Thanks, Alex. I think we can pop over now to Miria's talk. Should be pulling up. Okay.
Okay, let me try to rearrange my slides here in a useful way. Okay, yeah, so this is the other proposal, and the main change we did with our latest update is that we now have two kind of modes. One we call tunnel mode, and the other one we call flow forwarding mode. And tunnel mode is to support the case where the VPN case, or also maybe the network-to-network case, where we actually have a full packet with the IP header that we forward. So the client requests the tunnel to the proxy, and in this mode we actually require the client to be authenticated, meaning that the proxy somehow knows the client and has a certain amount of trust of the client. Then the proxy only inspects the TCP packet, the IP packet, sorry, and checks the source and IP address, the source and the destination IP address, confirms that this is allowed for the trusted client, and then just forwards the packet as it is. And then in the second mode we have is the flow forwarding mode, and that's the mode that we already had in the draft before. And that's where like the client actually requests a connect IP basically on a per flow basis, but it actually doesn't have to be like one strict end-to-end connection. It could be multiple, but the idea is that you send one connect IP request per flow. And you, so that means you provide like one specific target server that you want to send this to. So this means also that it's not possible to establish this flow from outside. It has to be the client. And in this case, it's super easy because it's also very similar to Connect UDP effectively. And it's easy to reduce the overhead by creating the IP header at the proxy. So this is now the two modes we propose. To go a little bit more into detail, I mean, the semantics is definitely something that we can discuss, and like how to use headers or encapsulates or whatever, or frames. But the idea of what we have currently in the draft is that in tunnel mode, the client would send a connect IP request and providing the IP address of the proxy here in the authority field. And there's one IP header that is required, which is providing the IP version. And then in this example, the client didn't request a certain IP address or IP address range to be used. And so the proxy in its reply will actually provide the assigned IP address to the client. So the client just has the knowledge about which IP address will be used by the proxy, and then can put it directly into the packet, or the proxy could actually rewrite the source address as well. Then the tunnel mode also kind of works for this network-to-network use cases. In this case, the proxy, the client can already request an IP address that it wants to use, or even an IP address range, and then the whole thing works very similar. So basically, in tunnel mode, having the IP address here is optional depending on what you need. And then in the flow forwarding mode, you send a connect IP address, and here instead of providing the proxy IP address, you actually provide the target IP address or an URL that can be resolved by the proxy. And here, because the proxy also creates the IP header, the one required mandatory header is the IP protocol field, because that's really the only mandatory information that the proxy needs to create the header. Everything else the proxy can decide effectively. There might be additional things you want to provide, but it's not mandatory. For example, we have we also propose in the draft an additional header, which is called IP address handling. So this header, for example, can, if you open a second connect IP request for another flow, for example, you could tell the proxy that it should use the same out-facing IP address for that, or a different one. And then we also have another optional header defined in the draft, which is called con ID. And this is to provide additional information for flow mapping. So instead of just using the source and IP address, if you have multiple flows to the same target, you can actually provide another field that could be used for mapping. So that could be, for example, the quick connection ID, or it could be port numbers or whatever. It's actually opaque to the proxy, but it makes the mapping easier. So this is like how the two methods basically work. We have much more details in the draft. But this is just like the rough overview about these two modes. We have a little bit of text about ICMP handling for flow forwarding mode, because as you don't provide the IP header in this case, you actually need to use context IDs for providing ICMP messages, and we don't provide all the details, but we discuss how to use context IDs for that. So that's like one really nice use case for context IDs. We didn't specify it fully, because we were not sure about the negotiation and how all the details work, so there's more work to be done. And then another example for use of context IDs is ECN support. This is also something we discussed a little bit in the draft, but actually for ECN support, we had like even more open questions, because there are different ways in how you want to use context IDs, like multiple context IDs for each code point, or just one for ECN support and then have an additional field or whatever. So there are many different solutions and trade-offs. I have one more summary slide, but Eka, go ahead.
I'm just getting a little confused here. If what I want to do is, like, as I say, this thing where I pretend to be in Europe, but I'm actually in the United States, how do I do this? How do I do it with the tunnel mode?
So if your proxy is in the United States and has an IP address, you just like open a tunnel. You don't even need to request an IP address. This IP address that the proxy provides to you is just like to tell you what your out-facing IP address is, because that might be useful for the client.
So sorry, I think I'm still
Maybe I can clarify. I mean, basically,
yeah, please.
In that,
yeah.
yes. So in this case, you send request to the proxy. The proxy gives you back the IP address. You write IP packets with that address as source address. Otherwise, it looks like you're on the LAN of the proxy, basically, and it will outside whatever router it has will forward the packet, etc., and get out.
Okay, so just to see if I can recap. Like I say, give me an IP address. It gives me an external IP address that it is selected, and then I put that in all my packets, right?
Yeah.
Okay. Thank you.
Okay. So yeah, so to maybe just like what's the main message here is that what we propose right now is a connect IP method that can have these two different modes, and therefore support different use cases in different ways most appropriately. And the tunnel mode, we in the draft say this requires more trust to the client. So the assumption is really that the client is known to the proxy, and the proxy knows, like if the client requests a certain IP address or IP address range, that the client is allowed to use that. We don't have any kind of route negotiation here, because the assumption is also that the proxy might know which targets the client is allowed to connect to, and like we just assume that this information is like negotiated outside the protocol or pre-known, pre-configured, or whatever, or it could be an extension in the future, but it's not here in the base version of the draft. So, and in flow forwarding mode, this is actually very similar to Connect UDP, just like for other traffic as well, not only for UDP traffic. And so this is why we propose it, because it's like if you have Connect UDP, like you have mostly implemented this already, and it actually can produce packet overhead. And so basically what you need in addition to Connect UDP is just knowing what the protocol layer number is, and that's it. And then you use the same methods as for Connect UDP, basically. And that's it from my side.
Ecker, are you still in the queue? If not, David, I think you can hop in.
Clarifying question. Thanks for the presentation. So in terms of like what the chairs were saying, we got consensus in the working group to that we needed to solve the first 3 use cases described in IP proxying requirements. That was consumer VPN, point-to-point connectivity, and point-to-network connectivity. So in the point-to-network connectivity, let's say that my laptop wants to connect to my corporate VPN and have access to the various subnets on my corporate network, but still, send most of my internet traffic over Wi-Fi. How does your draft address that use case?
So that's would be the classical tunnel mode. Basically this, right? So you just connect to the proxy, you open a tunnel, you don't provide any kind of target information or whatever, and you get an IP address assigned by the proxy, which is the out-facing IP address, and everything, and you can just send to any endpoint on that network the proxy is connected to, and anything that gets sent to this IP address is also forwarded to you.
And how do I know which networks the proxy is connected to? So like the subnets of the intranet, how does the proxy communicate that with me, the client?
So that is supposed to be pre-known knowledge, right? You have to know the proxy, and you have to know what kind of capabilities it gives to you.
That's not what any point-to-network solution does today. If we're talking, IPsec or things like that, so that seems like a miss. But okay, thanks for the answer.
Echo, you.
So I think, I mean, could you motivate the flow forwarding from each a little bit more? Like, is this primarily about you know, is primarily about like packet size? Like, what's the sort of like primary motivation for this?
Yeah, so it's wait, this slide. As I said, it's just very similar to Connect UDP, and so it needs like a minor additional information, and then you can use that, and you get the packet reduction. So it's like, why not doing it, right? And it's for all those use cases where you actually want to handle things on a per flow basis or on a connection on a per target basis. That's it.
Yeah, I think so. Maybe I'm arguing. So like, so I'll try one more time, but then I'll stop. I guess as an implementer of this, I'm just trying to understand how to like why it's beneficial to me. Like, you know, if what I'm doing is like an IP doodad, and I don't want to use Connect UDP. I mean, we had this discussion, I guess, with earlier, like about like if I'm not using Connect UDP, why would I not just connect up an IP tunnel? Why does this make my life easier?
So if you want to use TCP, for example, then Connect UDP doesn't work for you here, right?
Sure, but you connect for that, right?
You still might want to have the same properties where on a per flow basis, you actually want to control your outside facing IP address. And that's something that you cannot do on a tunnel. You have to do it on a per flow basis. And that's what this gives you here. So it's all the same use cases where you would use Connect UDP, but if you don't have a UDP-based protocol.
Okay. I guess, but wouldn't I just use Connect for that?
Not if you want to have a full end-to-end connection that is not interrupted, right?
Okay, thank you.
Hi, I have a quick clarification question. Do you need to maintain connection status on the proxy? And how do you get the packet back to the source?
So you need to have state per connect IP request.
So what if you have a load balance kind of model for the proxies? How do you ensure that?
What do you mean by load balance kind of model?
Like multiple instances of proxy.
You would open your connect IP address only to one specific proxy. You can of course use multiple proxies for different connect IP requests.
So what if the server responds back to the different instance of the proxy?
The out-facing IP address of the proxy should bring you to the right proxy. And if you're in tunnel mode and you use an IP address of your choice, then you should only open that tunnel to one proxy, I guess.
So for that, you need connection symmetry kind of model. Is that right?
What do you mean by connection symmetry kind of model?
The traffic always have to come back to the same proxy. Is that right?
Yep, usually I would think so, yeah.
I see, thanks.
My next, thank you. Yes. So just to reply to Ecker's point, and Mary, let me know if this is correct for thinking about the flow forwarding mode. Because actually the flow forwarding mode sounds very attractive to me for kind of like the client privacy proxy mode, you know, not a full VPN. I'm trying to get on my internal corporate network. So one difference I do see here is that unlike a VPN and unlike the case where I have to get assigned an IP address, like I may not want to have a single IP address assigned to my client because like I may not want to have inbound connections for security reasons, or like I don't want this to be a new way to get to me. And like what we're doing for Connect UDP and Connect with our private relay, like we are sharing an IP address between many clients intentionally to have better anonymity when we're doing things. So being able to say, I just want to connect to target.example.com and please put me on an address that other people can use that I have no claim over is an attractive property. So I don't want to lose the ability to do that. And then, so my impression of how you would use these is that, if I'm doing UDP, use connect to UDP. If I'm doing connect, most of the time do connect, but let's say that I'm picky about like congestion control end to end, or I'm trying to do some new TCP option, then I could just do connect IP and put TCP frames over it. But I think realistically, I would use this mode for if I do want to be able to use ping, or right now our system APIs, we let people do custom IP protocols, and maybe that's ESP, but maybe it's something else. And it's not really a fully fledged solution for how you want to access external sites until you allow all of those. So I think it's a valuable thing. And yeah, so I guess that's how I was interpreting it.
Yeah, that's exactly one of the use cases, and the point also about using this, which is like very similar to Connect UDP and not using the traditional Connect, is like, as you say, it's like a complete end-to-end connection. So maybe you have different controls about congestion, but it's like very similar in the way you use it. So it's very easy to just switch from one to the other. David.
Swap over to our discussion session, since it seems like we're starting to stray farther afield from just plain clarification.
Do you want me to stop sharing, I guess, then?
I have a couple of questions, but then, David, keep going.
Cool. Yeah, thanks. So I mean, it is somewhat of a clarification, but I think maybe a segue into discussion. I'm very confused. So the tunnel mode you describe is kind of like, doesn't seem fully specified in your document. It's good that you added that in the last revision, but it really sounds like your document's focusing on the on the flow mode, and that's like the majority of the text in your document. And I have a hard time understanding what problem the flow mode solves. Because I think, like, for example, Tommy's idea there just sounds like what you want is a NAT. And from, the implementation of every kernel on the planet, it's a lot easier to have like RC 1918 space from you to the VPN server and then a NAT. That's like how everything works these days. And if you don't have Apple's crazy user space networking stack, that's kind of what you have to do. So maybe help me understand, like, if we, maybe up level the conversation a bit, Maria, of what use cases, what things that we, are in IP proxying requirements does the payload mode solve specifically? Sorry, the flow mode.
Yeah, so it's a NAT functionality, but this gives you control about it, right? Usually it's not the client that can actually select the IP address or provide any kind of hints about which IP address they want to use or not. So this gives you control about it, and also having a way to handle per flow handle flows on a per flow basis means you can actually provide additional signaling or optimizations for each flow if requested. So that's some of the use cases that are very interesting for us.
So I have a hard time understanding the use cases, but especially, are those in the list that we've been discussing as a working group in IP proxying requirements, or are those something separate that you're interested in? I think that's fine, but that's what I'm asking to clarify.
I mean, like the list that is in the requirements document is very generic, right? It doesn't really talk about specific use cases. We did talk about these kind of use cases when we had the first BOF or before the first BOF, where like,
well, I mean, I guess the point that I'm getting to is, like, if we're discussing about, picking a proxying solution where we're going, I think, the focus should be on the use cases that we agreed on as a working group. And that's why, in our draft, there are things about network to network that we decided as a working group wasn't to focus. So that makes sense. And I'm all right, backing up on those things. But it sounds like for your document, unless I'm misunderstanding, and that's why I'm asking these questions, which maybe I am, it's like the use cases that you really are describing that you care about the most sounds like things that aren't in like what we've been agreeing to work on, unless I'm
I
mistaken.
don't know. So this for me, this is the point-to-point use case. I don't know what you've been thinking about this for the point-to-point use case, and
So
having
the
this
point-to-point use case isn't what you're describing. Point-to-point use case in IP requirements is when you have think IPsec, the opposite of tunnel mode. I'm blanking on it. Sorry, where your end-to-end connections, let's say your TCP, is from your IPsec client to your IPsec server. There's no routing involved at all. And that's not what you're describing. You're describing going through that to go somewhere else. So that's not point to point. I think you're describing like the consumer VPN use case, right?
It would be a modified version of this consumer VPN use case, but you could see it like this if that's where you want to move in future, right? So it provides you an ability to connect to targets outside in an outside network, but it provides some flow awareness to the proxy, which allows you to provide additional optimizations at the proxy if requested.
Okay, thanks. Yeah, so my personal intuition is that you're offering many features that don't seem to solve problems that we have, but I'll let folks in the queue comment further.
I just want to comment on this. You said like most of the text in the draft is about this flow mode. So you're right that we just added the tunnel mode. So there are like maybe a bunch of details missing, but it's also the case that for the flow forwarding mode, I think we have a lot of redundancy with the connect UDP draft. So it's not like it's more it's in some sense more complex, but if you compare what's the offset between the flow forwarding mode and connect UDP, then it's really minor.
All right. I guess, David, I think you're getting a little bit hung up on the process here, and I get that you want to defend kind of the approach your draft is taking. So one thing I would say is for the full tunneling perspective, I think the other draft that Alex presented earlier, like I think it's a lot more fully fledged and thought out for all of the different use cases you can have for assigning IP addresses. That's very, very good. We don't want to lose that. At the same time, it has a very, it's adding a lot of complexity that is very useful sometimes, but I think there are aspects that we need to learn from this document here, especially in the flow forwarding case, of things that give clients valuable features that also allows them to really simplify what they're doing. So, you know, all of this, yeah, you could build with a more complex negotiation where I have to get an address assigned to me and it happens to be a private address and I hope the thing's doing a NAT for me and then I do all these other steps. But it would be great, because we're not talking about just requirements, but we're actually talking about the protocol solutions, to be able to have a version of the solution that does look more like the flow forwarding mode for the clients that want the simpler, just I want to forward through a NAT, essentially. I just want to be able to talk other IP protocols. Being able to connect to something by a host name, not have to do a DNS lookup, not have to wait for an RTT of getting assigned an address in order to be able to send a query. Like, those are very important things for reducing latency, and maybe those didn't show up in the requirements document, but they are you know, important for the real world usages of this. When this flow is not a full VPN, but maybe it's just a very short-lived, I'm doing a ping to somewhere. So I guess I would encourage us to, like, you not just throw one of these out. Like, let's keep the good parts of Alex's draft of like all the complexity of how you can handle the synchronization of IP, and like that's very good. But let's not just dismiss what the simplicity of this flow forwarding case, because otherwise I think you're making this more complex and losing out on a lot of things that that's the main use case I would find attractive to adopt, far more than any of the other stuff.
So if I may jump back just for 2 seconds there, I apologize if I was suggesting we dismiss. That wasn't my intent. I'm not trying to be
or having the require like, oh, this is out of scope of requirements. This is not what we're working on. Like, I think these are good observations that fit into the requirements.
We decided to do with this working group. Like, I would have been fine jumping into solution building. We decided to do this requirements, and we landed and had some consensus here. And like, I'm the last person to throw process on the table. But if we decided to do this exercise together, there's a reason for that. So I'm just trying to understand what this specific adds over Connect and Connect UDP. But happy to take it offline. Please don't. I'm not trying to be dismissive here. I apologize if it came off that way.
My perspective is that it is not necessarily not the only way to meet the requirement, but it is a way to meet the requirements for one of the use cases in a very efficient way for the client. So let's keep that.
Yeah, I'm really just also hoping that we converge here to a common document rather than just like adopting one solution and throwing the other way. Ecker?
I actually just checked with Ecker because I want to answer Tommy directly, and he said I could. So one thing, Tommy, that I do want to say is in the use case that you described, it is unfortunate that we did miss it when we were doing the requirements gathering. I would definitely like to better understand what you would like to do and the sort of flow that you were describing, because I think that's actually different than the way we were previously envisioning the flow mode that Miria is describing. And I do see value in supporting it. The thing which I'm a little bit unsure about in understanding how it fits in is usually things like these pings and whatnot are done by OS kernels. I understand that there are some folks who have user-space network stacks and they have a little bit more flexibility here, which makes a lot of the things that you're describing possible that we weren't previously talking about in when we were going through the requirements. And if you do have one of these use cases like this ping, if there's something concrete that we can do to learn from it, I very much would like to know how we can support it. Because one of the things which I believe we have done well in the draft that we from the Google side have been presenting here is I actually think the complexity is fairly limited. I think that the messages we described in the capsules there, like they don't actually enforce a particular flow. And I think that we actually do have the flexibility to build a solution which provides the capabilities that would work well for tunneling and flow forwarding if we also understand these latency requirements and what's generating these packets and just in general how we expect it to work. I very much understand and appreciate the desire to have a like one-shot flight mode which gets all this done, and I believe we can build it. Thank you.
This is actually a clarifying question, I hope, and then maybe a comment. So if I just I'm sorry to be going back to this point I asked earlier, but so if I just want to do a ping, right? I do not actually need the assigned IP address, correct? So I just say connect IP to wherever the heck I want to go, and I can chase that with the ping directly. I don't have to take a round trip. And the IP address is like just informational. I can ignore it. Is that correct?
It was Tommy's use case, but I guess so.
Well, I mean, I think this is a really important question because if I have to take a round trip in order to do this, and that's much less attractive. So I think like it's important to understand whether or not like do I have any like do I have to format like do I have any useless IP address if I don't care what it actually is?
So in flow forwarding mode, you definitely can send 0 RTT data, and you can just send your ping out directly. I guess you could also, even in tunnel mode, you could send out data directly if you read the IP address, depending on.
I don't care tunnel mode in this case. I'm asking out flow forwarding mode.
Definitely yes.
So Ecker, I think my question is, what's processing the ping response? If it's a host kernel, in today's operating systems, the IP address is required in order to be able to associate that this is an ICMP ping response that is destined to you. If it's some sort of user space stack, which is what Tommy was implying, and there is some work on the proxy, which is ensuring that only the response which is destined for you is coming back to you, then yes, I agree, it is possible to not need to care about the IP address. But at that point, what we're basically creating is something which is less connect IP and more like connect ping, which we could do. But that's sort of why I was saying earlier, I want to better understand what network stack is producing these things.
Well, I think there's the question. Maybe I was just being too strong about not caring about it. but I guess the case what I'm trying to avoid is taking an extra round trip in order to do this, because it seems to me that if I compare these mechanisms, right, it seems to me that the thing Tommy was advocating for was the ability to guarantee that you're having an unlinkable IP address for this transaction from previous transactions, and that is not a present, and that isn't something that is guaranteed by a but by sort of a classic pin up a VPN, unless we have some configuration setting that says that says I want this, and then you have to figure out how to identify which flow is which, right? So that seems like the attractive property. But if I have to, and so if it's one thing to be like, well, the IP address will come back pretty soon, and it'll probably beat the ping, and if not, I can hang on the ping for a little while. And it's quite another to be like, I got to absorb a full round trip before I can even send it back. Those are two really different things, right? So I guess so. Now I am in comment mode. And I think I'm gonna sort of I think we're really almost out of time. So the chairs I think need to do some work here. Well, I do not want to spend the next 6 months with everybody taking the pieces that they think are attractive in their proposal and ending up with two proposals that are very, very similar, and then it's having to on them back and forth. That is an awful outcome. It seems to me that people recognize that there are pieces of each proposal that some are more developed than the other, so perhaps you can find a way forward that does not involve that extraordinarily fun beauty contest exercise. But I could suggest one, but Professor Chairs is really their job.
All right, we are cheerfully at time. Thank you all for a really nice discussion there. I expect we will want to continue that significantly on the list. And one of the other things that we're going to start a discussion about on the list is how we as a group would like to go around kind of moving forwards with merging solutions here or picking one or the other, and making sure that we're all happy with the criteria by which we move things forwards. So we're gonna start some discussions on that. Please continue discussing this on the list. Sorry, Lucas, for our time not permitting, but that is the permitting part. Feel free to send a summary or anything like that to the list. I suspect folks would be interested in some of the content that would in your slides, having looked through them briefly myself. And with that, thank you all for coming, and we will see you on the list.